Hello everyone. This is Ambika from Provoke Trainings. I'm a senior faculty working in Provoke Trainings. I'm a senior data engineer working in IT organization. I have total 8+ years of experience in IT industry and 4 years of experience in data engineering as well as in Python development. Here, I'm going to provide you some of the interview questions for Snowflake or data warehouse. So we are going to see some set of questions here, maybe from 5 to 6 questions. These are the very important questions which is asked in the Snowflake interviews. I have given the questions from both the basic kind of question as well as the basic Snowflake data warehouse as well as with the advanced concept of the Snowflake data warehouse. As well as I have given some one question from the advanced SQL queries as well. Let us discuss in detail about this. What is the difference between shared disk architecture and shared nothing architecture? Snowflake data warehouse support this architecture, both shared disk and shared nothing architecture. Shared disk and shared nothing architecture are two different approaches to the database and data warehouse design. The main difference between the two is how they manage the storage and the process of data across multiple nodes in the system. So in this you are going to learn how the shared disk will be and how the shared nothing architecture will be. For example, here I have 3 CPUs. Similarly, I have 3 CPUs here. CPU. This is CPU memory. And this CPU memory. This is disk. This is disk. And this is overall shared nothing. Here I have CPU. I have CPU memory. I have CPU memory. So I have here I'm going to have disk. So this architecture is shared disk architecture. So what I am doing is every node, every memory or CPU or the warehouse will be having the separate storage. So each node will be having the separate storage here. So whatever the full data collections will be stored in the single disk. The entire data collection will be in the single disk and the entire data will be with this corresponding disk. This is called shared nothing. The shared disk means you are going to have the multiple CPU or memory which is going to share this disk. That is why it is called shared disk architecture and this is called shared nothing architecture. This is an important concept where the Snowflake data warehouse is going to work. I hope from this design, you must be able to understand here we have direct connection between the CPU and disk. The entire collection of the data of this node resides in the disk. The entire collection of this node resides in this disk. The entire collection of this node resides in this disk. Whereas the collection of this data will be residing here. So it will be sharing between these 3 CPU memory. This is called shared disk and shared nothing architecture. That is the basic concept behind the Snowflake data warehouse. In the shared disk architecture, the nodes in the system have access to disk storage, which means that any node within that system can read from or write to any disk in the system. This allows for high availability as a failure of the single node does not cause the data loss or unavailability. So in this, what we are able to understand, if any one of these node fails, as the data is distributed here, it is so any node can, this node can read and write from here, this node can read and write from here, this node can read and write from here. So if any failure access, any one of the CPU fails, the other two will be available. So the data will be reading and writing will happen parallelly. Correct? So this allows the high availability as the failure of the single node does not cause the data loss or availability. In these three nodes, any one node if it fails, so the data will be available through these three nodes. Correct? So it allows for a simple data management process as the data does not need to be partitioned or replicated across the nodes. Because it's already shared, it is distributed. These nodes are going to access from here. If any one fails, the data will be available with the other through two nodes. So there is no need for data partitioning or a replication across the nodes. So this is called the shared disk architecture. On the other hand, shared nothing architecture is when each node in the system has its own private storage. That is what? Each system has its own private storage. Correct? So, which is not shared with the other nodes. The data is partitioned across the nodes, which means each node is responsible for the subset of data. This node will be having the subset of data. This node will be having the subset of data, and this will be having the subset of data. So this provides a scalability as it offers the ability to add more nodes, each of its own storage and leading to the better performance. So what is this advantage is you can add one more node with share their own disk so that it won't disturb the other nodes. You can scale the number of nodes here and you can scale the number of disk storage as well so that each node will be independently having their disk storage. So Snowflake takes the combination of these two architecture. Shared disk means multiple nodes can read and write from the shared place, distributed one. If one fails, the other two will be available all the time. That is why in the cloud, the data should be always available. The Snowflake takes the support of the shared disk architecture so that if any one of the warehouse files, the data should be available in all the warehouse so that in the cloud, the data should be available all the time. So there should be any no loss of data. Similarly, it also helps for upscaling each warehouse size according to the number of the concurrent users and the concurrent queries. So you can upscale the number of CPUs as well as you can alert the disk storage for that so that each CPU or node will be having the subset of data which is stored in their own disk. So that's such a beautiful concept that Snowflake has got, that is shared disk and shared nothing architecture. This is a very important question being recently asked in the Snowflake interviews. Next is, can you explain the advanced feature Snowpipe is used for the continuous data ingestion? Snowpipe is a Snowflake's serverless architecture. It always supports for the continuous data loading. For example, in the S3 bucket, I have the set of files. Through the batch loading, I don't want to load the data batch by batch. Rather, I want to do the continuous loading. So whenever the data is available in the S3 bucket, it should be available in the Snowflake data warehouse. That is possible through the Snowpipe, that is Snowpipe serverless architecture. So the Snowpipe serverless architecture helps the Snowflake for data performance, data security, as well as data analysis. It supports a very important feature. This is a very important feature in many of the organization projects. They are using the Snowpipe for continuous loading from the S3 bucket. In one of our projects, we have implemented the Snowpipe execution of the continuous loading from the S3 bucket. So I have the Kafka sync connector and I have the files from the ABS, ADLS generation 2, GCS and S3. From these, I'm going to take the files. Through this Snowpipe auto ingest, I'm going to load the data into the staging table. The Snowpipe has got a copy command It has got a beautiful object called pipe object, which has got a copy command. The copy command requires the Snowflake stage and integration object. Integration object means you have to create the integration object between the Snowflake and the S3 bucket, so that whatever the files from the S3 bucket should come into the Snowflake stage. From the Snowflake stage, it should come to the staging table. This is the architecture of the Snowpipe. From this S3 bucket, you should have the integration object to the Snowpipe. That integration object will be connected to the S3 so that it can talk to the Snowflake stage to load the data files. And from the stage, using the copy command, it will reach the Snowflake staging table. The Snowpipe has got one channel, notification channel, which should be provided in the S3 bucket notification object, so that whenever the file comes to the S3, it will be notified to the Snowflake using the Snowpipe notification channel. Then it will be loaded into the staging table, and then do the transformation, and the refined tables or the target tables are getting loaded into the Snowflake. So using this Kafka also, we will be connecting the SDK and we will be loading the rows into the staging table. But main purpose of Snowpipe, which is going to load the data from this different types of this source provider. This is also the advanced feature of the Snowpipe, which is used in the continuous data ingestion. Snowpipe is a continuous data ingestion by Snowflake that can load files within a minutes. With the Snowpipe, you can load data into small groups, micro batches, allowing users over the organization to access the data within minutes, making the data easier to analyze. Users specify the cloud storage path where the data files will be placed, and also the target table in the Snowflake. So they have to give the two inputs. First one is cloud storage path where the data files are placed. Other one is target table in the Snowflake where the data will be loaded. This will be automatically this is an automated loading process in which Snowpipe automatically detects the new files that has been added to the storage path, to this cloud storage path. So we have two things here. One is cloud storage path where the files are residing, and you need the target table in the Snowflake where we are going to load this data. The Snowpipe going to detect the files automatically from this storage path. Once these new files has been detected, Snowpipe ingests this data into the Snowflake and load into the specified table. This is architecture. Just now I explained using this what is Snowpipe and what is the integration object, what is the stage in the Snowflake. The integration object and stage should be linked. So using this copy command from the stage, the data will be loaded into the Snowflake data warehouse. And it has got a notification channel which should be ingested to the Snowflake S3 bucket notification property, so that whenever the files are ready, it will be notified to the Snowflake, and from there it will be automatically loaded into the Snowflake data warehouse. So this near real-time process ensures the data is available as soon as possible. Whenever the file comes to the GCS or S3 bucket, through this Snowpipe, it will be immediately available in the Snowflake. The Snowflake operates on serverless architecture, meaning that it automatically manages the compute resources specifically required for the data ingestion process. So how many resources are required? If it is a very less number of resources, or more number of resources, it will auto scale it and auto scale it down so that it should meet the requirement. It is on-demand basis. So whenever I'm putting some files in the S3 bucket, using this Snowpipe setup, the file should come to the Snowflake in few minutes. This is the way how the Snowpipe is going to work. Next question, explain the concept of fail-safe in Snowflake and how it differs from the time travel. Fail-safe is a data recovery feature in Snowflake designed to restore the data that has been deleted or modified beyond the time travel retention period. So whenever you are going to create a permanent table or transient table or temporary table, you know that what is the time travel and retention period for this permanent table, transient table and temporary table. Let us take it as a permanent table. So mostly the time travel period will be 7 days, or it will be up to the 90 days, up to the enterprise edition or the standard edition. So when I'm going to store some data, unfortunately, it got deleted or got modified in my database. So to access those data, I should use the concept of the time travel to whatever the data got modified or deleted. But still, I missed the time travel period. Now I have only the file safe period to recover the data. So in the time travel period, I can use the queries to retrieve the data, whereas in the file safe, I cannot do it by myself. I have to take the support of the Snowflake admin or Snowflake support people to retrieve the data. That is the concept behind the file safe. It is a data recovery feature designed to restore the data that has been deleted or modified, while time travel allows us to access the historical data within the set time frame. Failsafe is a 7-day period after the time travel, during which the Snowflake retained the data solely for the disaster recovery. So, failsafe is only for 7 days, that is after the time travel period. First, you have to try accessing those deleted or modified data using the time travel period. If you miss the time travel period, then only you have to come to the failsafe period to access those data. Unlike time travel, users cannot access the failsafe directly. As an intervention from you have to take the support of the Snowflake to do that. Failsafe provides the additional layer of the data production but incurs higher cost and should be used for the last resort after the time travel. So the failsafe can be accessed only if the time travel period is over. And that one also we cannot do it directly. We have to take the Snowflake support team. But whereas in the time travel, by giving the time frame, we will be able to access the data. This is also the important concept in Snowflake. So in this fail-safe, the standard operations allowed are current data storage. In this normal queries, data definition language, data manipulation language, these are the operations I'm going to do in the current data storage. In the time travel, I'm going to use the select statement at this interval, before this time or after this timestamp. I can clone the database or clone the particular table before this particular timestamp or after this timestamp so that the history record will be retrieved. Whereas no user operations are allowed in the file safe, it is only taken care by the Snowflake people. This is called the continuous data production lifecycle supported by the Snowflake. So these are the things we have to explain when we are asked for what is the difference between the file safe and the time travel. Now, what are the different types of the caching in Snowflake? We have 3 types of layer in Snowflake. They are cloud service, virtual warehouse, and database storage. So we have 3 types of caching here. One is result cache, metadata cache, and virtual warehouse cache. Result cache means that happens in the cloud service layer. All query results stored for 24 hours unless until underlying data changes. Identical queries are returned instantly without requiring compute. So in this result cache, the result will be stored for 24 hours unless until the underlying table data is not changing. If it is changed, the data will be changed in the result cache. Identical queries are returned instantly without requiring the compute. So if you are going to use the same queries which is executed recently, so without the compute, you will be able to execute that query. This is about the result cache. In metadata cache, which is coming from the virtual warehouse, it improves the compile times for the queries against the common used tables. So using this metadata cache property of the virtual warehouse, the compile time will be improved for queries against the common used tables. It is going to give the efficient compiling time for the queries so that the cost will be reduced and which is going to access the commonly used tables. In the database storage, this is called virtual warehouse cache, which is called data loaded into the warehouse is stored in the local SSD storage. Cache entries are invalidated if underlying data changes. So in the database storage, here in the cloud service, we have the result cache. In the cloud service, we have the metadata cache. And in this virtual warehouse, we have the virtual warehouse cache. There is a small change. I did not explain the arrow before that. So this result cache belongs to the cloud service layer. This metadata cache which belongs to this cloud service layer and the virtual cache which belongs to the virtual warehouse. The data loaded into the warehouse, it is stored in the local SSD storage and cache entries are invalidated if underlying data changes. Once the data changes, the cache will become invalidate. This is for the virtual warehouse cache. For the metadata cache, it improves the compile times. The cloud service layer will be taking the metadata. What is metadata? If you are going to take the file from the S3 bucket, what is the file name and when the file got stored in the data warehouse? Those are the informations about the files. They are the metadata that is maintained by the cloud service layer. That is why it is called as a metadata cache. This helps us to improve the compile time so that you know from which file and what time the file got loaded. I'm going to load those data from the files to the Snowflake data warehouse. So this is about the metadata cache. The virtual warehouse cache is stored in the local SSD storage. Once the data changes in the underlying table, this become invalid. Database storage is nothing but the Amazon S3, which is a storage layer of the Snowflake warehouse. So these are the three types of the cache in the Snowflake data warehouse. Now coming to the what is rank and dense rank in SQL? What is rank and what is dense rank in SQL? These are the two statements and two important concepts in the advanced SQL queries. For example, I have a table here. I have a set of names and set of marks. 95 and Bob and Charlie has got 90. Then David has got 85 and Eve has got 80. Now, the rank function assigns a rank to each row within the partition of the result set. If multiple rows have the same value in the order by class, they receive the same rank and the next rank in the sequence will be skipped. So this is the definition of the ranking. When I am going to explain this example, then only you will understand this theoretical part of this. The query for this is select name, score, rank over order by score, descending order as the new column name from the scores. So I'm going to select name, score from this scores table, rank over order by the score in the descending order. This is the syntax we have to follow for this query. In this, Alice, Bob, Charlie, David and Eve, I have 5 names. I have 95, 90, 90, 85, 80. So the rank 1 will go for 95 and 90s will be having rank 2 and 85 will be 4. Actually, this should be 3. But in the rank, it will be 4 and 80 will become 5. This is about the rank. If the multiple rows have the same values, so the two rows having the same value, they receive the same rank. Yes, they are receiving the same rank. The next rank in the sequence will be skipped, so that's why it is displaying 4. This is about the rank statement. So this is about the definition of the rank. This is the query what you are going to use for the rank, and this is about the result. So in this, what is the thing? The two ranks having the same number will be having the same rank and the next rank will be skipped. This is about the rank statement. So in the dense rank, also assigns a rank to each row, but unlike rank, it does not skip the rank whether or ties. Tied rows receive the same rank and the next rank in the sequence will be consecutive. The syntax is select name, score from the table score, dense rank over the order by scored column, descending order as a new column name from the scores table. So this is the definition and this is the syntax of this dense rank. In this result, you are able to see 95 having the first rank, 290s having the second rank, and 85 is coming to the third rank. So it is not skipping the next rank. Rather, the same row having the 2 marks is holding the same rank. And for the next row, instead of the 4, it is giving 3. So now it is in the sequential order. This is the difference between the rank and the dense rank. This is a very important SQL advanced query. This will be asked frequently in the interview questions. So you should know why we are going for the rank and dense rank. What is the difference between the rank and dense rank? And you have to explain with the definition, with the simple syntax query and with the proper data. This is about the advanced SQL query concept. Thanks for watching. Don't forget to stay tuned to Provoke Trainings for more exciting content like this. Please post your queries and enquiries in this below link. Here we have given the form where you can give your full name, mobile, mail ID, location, which course you are opting for, and you can submit this form. So when you submit this form, whatever the queries given by you, whether you need the more exciting content for this course or if you need registration of this course or you want to enroll for this course, you will be getting a call from our respective department for further more queries. Please submit your queries in this form. Signing off, Ambika. Thank you so much.